Hey YouTube, in this video I want to talk about the stretch-shortening cycle. So in my last video I kind of ran over the stretch-shortening cycle slightly for the mechanics of your arms. And I just want to talk about why the stretch-shortening cycle is so important and what it actually is. So similar to an elastic band, the more you stretch it, the more it's lengthened and the more it wants to shorten back to its original position. The stretch-shortening cycle just mimics that. It's where active muscle lengthening is followed by active muscle shortening. Different from an elastic band though, your body, the second it reaches its peak stretching, it wants to go back. It doesn't really give you this, okay, I could go back to my shortest position, but there's not really much resistance, so I don't really care. It just tells you when it's met its maximum. Obviously, you could probably train to know when your muscles are close to being at a maximum and the far away, but that's not important. What's important is once you've hit the maximum, knowing when you've hit the maximum and knowing when you need to stop. Because similar to when with an elastic band, if you stretch it to its maximum, it wants to go back as much as possible. The second you've reached this maximum, if you was to continue to stretch, you wouldn't be making it any longer. You'd snap it, which is an injury. And also, it would just be inefficient because once you've done that, saying it managed to survive and it didn't just break, now it's lengthened slightly and it's going to be longer and it's not going to shorten back to how much it was, because in this scenario what's really important isn't so much the rubber band snapping back to its original size, but it's the rubber band's distance from its original size, the difference between its original size and where it was going. For example, let's use this pen. Let's say there's a rubber band that's this long and I stretch it to the size of this pen. What's important isn't getting the rubber band back to the size of the pen lid, but it's the distance between the pen, the distance we stretched it to here and where it was before, which would be this much from here to here. However, there isn't really anything short I have. This will work. However, no, it won't. However, let's assume that we stretched it, but we stretched it further than it was supposed to. So we stretched it beyond this pen, which was in this case its maximum, and it's shortened back down to halfway along the pen. So now it's shortened down to here instead of here. When we stretch it again, it's only going to shorten this much, and the less it shortens by, the less it can travel to, the more energy is required to make it travel that distance. And it's almost crazy to even think about trying to get the elastic band to travel to, let's say we could get to travel 10 meters before. If you stretch it beyond and it survives, we try to stretch it again, it might not travel 10 meters, it might just travel 5. And your body will behave the exact same way. Obviously, your body's slightly different. So after a race, your tendons are gonna cool down and they're gonna just go back to the original position after a while. And obviously after training too, that's gonna happen anyway. But the fact that you stretched it beyond where it's supposed to be would mean you're just wasting energy that you could be putting towards producing force. And not just that, but this was energy you're dispersing to try and produce more force when the maximum force was already reached. So this isn't very smart. Now you might be thinking, okay, that's great, but how does this actually transfer to sprinting, getting faster? I mean, I know my body is now an elastic band. Where's the correlation? The biggest correlation, the one that's the most obvious, would be your arms and your legs. But not just your arms. Like, I mean, I've already done a whole video on the arms, but specifically the legs when they're going upwards. So think of it like this. When you're sprinting, obviously you're trying to get your knees as high as possible. You want to stop getting your knees high once you feel that stretch-shortening cycle. When you feel it's usually when you feel your hips tighten. It's like, okay, now it's time to push down and release all that force. This is where the stretch-shortening cycle would be. Probably the best example and the most useful one. So if you was to hit that point of where your hips are really tight on the sides and now it's time to go down, resisting that and trying to raise your knees even higher would be a waste of time, complete waste of time. But you might be thinking, but if I have my knees higher, I have further distance from the ground, so I can have more time to produce more force into the ground and a bunch of other things. And you'd be correct. Problem is your body isn't capable of lifting its knee that high, so don't try to force it to go that high. But that doesn't mean you can't produce more force. If you want to produce more force and still follow the stretch shortening cycle, which is really the only way you can produce more force, it would be to loosen your hips, because your body isn't just a straight elastic band going up to down. It's one elastic band from the tips of your toes to the top of your hair. It's a bunch. And loosening some and strength and tightening some would benefit you. And you want to get this right ratio of tightness to loose. Well, not so much loose, but mobile. And your hip is one of the things that you really want to be mobile, so that you can actually produce more force into the ground, because your knee can go higher. Obviously, it can go higher because you can get higher. Like, you can probably get, maybe you can't get your knee to your chest, but you can probably get close to getting your knee to the chest, for example. So if you can get your knee to the chest without moving at high velocity, doesn't that mean you should be able to do it moving at high velocity? Yes, it does. But the problem is, when you're moving at high velocity, you're repeatedly stretching your tendons over and over again at such fast speeds that they're not able to respond. Because, for example, you can probably get your knee to your chest, but you probably can't just raise it up to your chest. You probably have to let it come, then it's going to hit a point where it can't go any further, and you just slowly pull it towards you. By doing that, you're just loosening the hips, so you can, and you're just kind of moving them out of the way so you can actually pull it up. But if you used to try and stand up like that and produce force with that, you wouldn't really go high, which is the point. You've gone beyond what you're actually able to do. But if you was able to loosen up your hips to the point where you're able to raise the height of your knees so that you can produce more force, you're still following the stretch shortening cycle, and now you're able to produce more force with just one simple fix. Actually, two simple fixes. First, you followed the rules of the stretch shortening cycle, which there's only really one rule, which is once you feel that tightness in your body, once you've started moving, you need to just let go so you can actually use that velocity. Because if you continue pulling back with your arms or your legs, it's just like having an elastic band and then you let it go, but you put your finger against the inside of the elastic band, and then you just feel that side pull in, and then this side moves your, maybe, I mean, probably won't move your hand, but you get the point. You're just wasting energy. You don't want that to happen. You just want to follow the stretch shortening cycle, just follow what's happening with your body so that you can use the force more efficiently. If you do that, you can get faster. Just follow the stretch shortening cycle, that rule, and then for this case, loosen your hips so they're more mobile, and you'll be able to lift your knee higher to produce more force.